Plus 5 cos theta. So we want to use the Marvel's theorem. So this was part B. And let's start part C down here. So using De Moivre's theorem, first we need to remember what De Moivre's theorem is. De Moivre's theorem started by saying that the cosine of theta plus I sine theta raised to the nth power. So cos theta plus I sine theta raised to the nth power by De Moivre's theorem, this is equal to cos n theta plus I sine n theta. All right, this is De Moivre's theorem. And we're going to use De Moivre's theorem to prove this question. Cos n theta plus I sine n theta. Now, if you're to let n be equal to 5. If you let n be equal to 5, what are you going to get? If you call n equal to 5, all right, so let me write it here. Let n be equal to 5. If we put n equal to 5, what we're going to get is the cosine of theta plus I sine theta. All of this is raised to the 5th power. So cos theta plus I sine theta raised to the 5th power, that is going to be equal to cosine 5 theta plus I sine 5 theta. Nice and easy. That's what we're going to have, okay? Now, one thing we notice is that this doesn't really help us in this form. And we have it as cos theta plus I sine theta to the 5th power. That don't help us. So we're going to have to expand this bracket. To expand this, I just want you to remember Pascal triangle. Let me put Pascal triangle up here, which are the coefficients of each term. Remember, it's 1. Then you have 1, 2, 1. Then it is 1, 3, 3, 1. All right. Then it is 1, 4, 6, 4, 1. And then it is 1, 5, 10. Then you add 4 to here, you get 10. You're going up by 1, you get 5, then 1. This is Pascal triangle, all right? It's easy to know. To look at this. You're going from 1, then you add 1, more, add 1, more, add 1 more. So you know down here would be 6. Right here now, you're going from 1, then you add 2, then you add 3, then you add 4. You do the same here, you add 1 here, and you keep 1s on the end. This is how Pascal triangle is. We look more into that when you check out the module 2 videos. Now let's get back to this. So we're going to use this one here. This is a coefficient of the 5th, the term with the 5th. So it's really cosine to the 5 of theta plus, this is going to be 5 cos to the 4 theta, 5 cosine to the 4 of theta, and that is being multiplied by I sine theta plus, it's going to be 10 times the cos cube of theta. Oh boy, we won't have enough space. 10 times cos cube theta times I sine theta square, I sine theta square, plus it's going to be another 10 Oh boy, it won't fit. So let's go around here. Plus 10 cos squared theta times I sine theta cube plus 5 cos theta times I sine theta to the 4 plus I sine theta to the 5th. Yes, I know it is very lengthy. It's very lengthy to write out all of that. I know. Plus I sine theta to the 5th. And remember, all of this is equal to cos n theta, which is cos 5 theta, plus I sine 5 theta. So all of this is equal to cos 5 theta plus I sine 5 theta. So now, after you get this now, what are you going to do? Well, you see, all of this now, what do you know about complex numbers? Two complex numbers are equal whenever their real parts are equal and their imaginary parts are equal. So think of over here as x plus, this is like x plus yi, and think of all of over here as a plus bi. So we need to identify the real parts. The real parts are going to be the terms without I, and the imaginary parts are going to be the terms with I. So this is a part of the real part, cos to the 5th. Now, 5 cos to the 4, I sine theta, that's imaginary. Now, I square is minus 1, and so this will be a part of the real. All right. I cube is imaginary, that's minus I. I to the 4 is 1, so that's real. All right. So by equating the real parts, so equating the real parts, by equating the real parts, what we're going to get is this cosine 5 theta, because remember this is a real part too. We're going to get that the right hand side cosine of 5 theta is going to be equal to the real part now. No, it's cos to the 5 of theta. So cosine 5 theta is equal to cos to the 5 of theta plus, let's look what around here is. Now it says plus 10 cos cube theta I sine square theta. Now I square is minus 1, so I'm going to rewrite this as minus 10 cos cube sine square theta. All right, so this is going to become minus 10 cos cube sine square theta minus 10 cos cube theta sine square theta. Then this part now we know that I to the 4 is 1. So I'm going to rewrite this part as plus 5 times the cosine of theta being multiplied by, instead of saying I sine to the 4 of theta, I to the 4 is 1. So it's just being multiplied by sine to the 4 of theta. It's just been multiplied by sine to the 4 of theta. Beautiful. Now what do you do next? Now notice that in the solution, everything is in terms of cosine. So we're going to have to do some substituting. So what we're going to then get is cosine to the 5, cosine to the 5th power of theta minus, now this sine square, we know sine square is 1 minus cos square, so we can rewrite this as minus 10 cos cube theta times sine squared theta, but sine squared theta is 1 minus cos squared theta. Don't you ever forget that identity from AdMath or Unit 1. Plus, then you're going to have 5 cosine theta. Now we're going to need an identity for sine to the 4 of theta. But sine to the 4 of theta, if I can break it down, is sine square theta all square. But sine square is 1 minus cos square. So it's going to be 1 minus cos theta all square. If you're wondering how did I get that? 1 minus cos square theta all square. Because remember, sine to the 4 can be looked at sine square square. And sine square is 1 minus cos square. So it's 1 minus cos square all square. All right, so now we can expand this. So expanding, we're going to get cosine to the 5 of theta minus, now 10 cos cube theta times 1 is minus 10 cos cube. Minus 10 cos cube theta. Now minus and minus give us plus, and so that becomes cos cube times cos squared is cos to the 5th. So we get plus 10 cosine to the 5th power of theta plus, now we need to multiply 5 cos theta by this square. So I'm going to do it in 2 steps. This is 5 cosine theta being multiplied by, we need to work out what is 1 minus cos square theta all square. That part is going to work out to be first term square minus twice the product of the 2, which is minus 2 cos square theta plus second term square. Plus the second term square is cos square is cos to the 4. I'm going to leave off the theta here, but we know it's theta. When I just write cos to the 4, we're talking about cos to the 4 of theta. This is cos to the 4. This means cos to the 4 of theta. So now we can finally write what everything is. So what this is working out to be is cosine to the 5 of theta minus 10 cos cube theta plus 10 cosine to the 5 of theta then cos to the 5 of theta plus 5 cos theta times all of this. 5 cos theta times 1 is 5 cos theta. Then you're going to have 5 cos theta times minus 2 cos square theta. You're going to get 5 times minus 2 is minus 10. So you get minus 10 cos cube of theta. And then you're going to have 5 cos theta times cos to the 4 theta. That's going to become 5 cos to the 5 of theta. So this is 5 cos to the 5 of theta. Okay, good. Now all you have to do is just add them. Now I notice I have a cos to the 5 here. I have 10 cos to the 5 here. And I have 5 cos to the 5 here. So when I add them up, what I'm going to get is 1 plus 10 plus 5 is 16. So I get 16 cos to the 5 of theta. That's what they had. Okay, so we have a good start so far. Next thing I notice, I have cos cubes. I have minus 10 cos cube and I have minus 10 cos cube. That's minus 20 cos cube. So that's minus 20 cos cube. Minus 20 cos cube theta. Okay, good so far. Now, what I notice is that we have Just 5 cos theta. And so we just write back that part and we get the proof. So you just put back here plus 5 cos theta. So this is it proven, all right? Nice and easy, soft. So you can just write QED, all right? Which you can tell them quite easily done. Nice and easy, soft, quite easily done. Easy question. Let's look at the next part. Part D. Part D is another complex part again. All right, so notice that they didn't give us much differentiation this year. They gave us more complex numbers. Part D. Part D says that write Z is equal to minus 1 plus I to the 7th in the form RE to the I times theta. So let me write that down. Z is equal to minus 1 plus I, and this is raised to the 7th power. All right. I need to write it in the form RE to the I times theta. Now, before we do this, what I like to do is to go from this form to polar form, and then from polar form to exponential form. All right, so I like to, if that is Z, I'm going to call another complex number. I'm going to call P. I'm going to call minus I plus 1 P. All right, think of minus I plus 1 as some complex number P. All right. To put this in polar form, what we know is that R is going to be equal to 1 square plus 1 square rooted. My apologies. And that's the square root of 2. So that is going to be R. The next thing you're going to need is to find the argument, but the argument depends on the quadrant that it is in. All right, so you have to remember minus 1 is here, plus I is here. So it's in the second quadrant. All right. Whenever it is in the second quadrant, it is pi plus tan inverse of y over x. All right. Once it is in the second quadrant, it's always the angle between this and the positive x-axis. All right. And so in this case, the argument of P is going to be equal to pi plus tan inverse of that looks like 1 over minus 1 is just minus 1. So you put that in a calculator, tan inverse of minus 1, which I should know, but that's minus pi by 4. And so the argument of P is pi minus pi by 4. And pi minus pi by 4 is 3 pi by 4, which makes sense. Based on our diagram, it should be 3 pi by 4. Yep, so correct. Based on our diagram, we can see that it should be 3 pi by 4. Doing a sketch always make you see what the answer should be. We know it should be between 90 and 180 based on our diagram. Yeah. All right, it's always good to give a sketch. All right, it's always good to give a sketch. So this is that. All right, now that we have P, next thing that we're going to need now is Z. All right. So now we can rewrite Z as Z is equal to, what is Z? Z is equal to R, which is the root of 2, R into cos theta, where theta is 3 pi by 4. So Z is root 2 cos 3 pi by 4 plus I sine theta plus I sine 3 pi by 4. And all of this is being raised to the 7th power. All of this, every little thing right here, so is being raised to the 7th power. All right, all of this is being raised to the 7th power. So if we're raising all of that to the 7th power, it's going to be root 2 to the 7th power, which I don't know what that is. So we're going to use De Moivre's theorem again. So it's going to be root 2 to the 7th power times cos theta plus I sine theta to the n is cos n theta. So it becomes the cosine of 3 pi by 4 times 7. 7 times 3 is 7 times 3, 21. I know it is really sad to put that in the calculator, but it happens to the best of us. So it's 21 pi over 4 plus I sine 21 pi over 4. All right, now I can put it in the form z is equal to re to the I times theta. Because right here, so I have it in, this is in the polar form, which they didn't ask for. So to put it in the exponential form, it's going to be r is root 2 to the 7th power. So it's root 2 to the 7th power e to the I times theta. E to the I times theta. I times theta is going to be 21 over 4 pi, 21 over 4 pi times I. All right, and that's that. That is z. Root 2 to the 7, e to the 21 over 4 pi times I. Nice. So that takes care of part 1. Now let's look at part 2. Part 2 says, hence, prove that minus 1 plus I raised to the 7th power is equal to minus 8 into 1 plus I. So we should hence, so it means using this, prove that this is equal to minus 8 into 1 plus I. So there are many steps I'm thinking of that we can use to prove that. But they said hence, so we need to use this principle. All right. No, that it's a good thing. That's why I did it this way, you know, guys. You see that? It's a good thing why I did it this way. All right. I'm so happy I did it this way now. So now for part 2, right? It said hence. So remember, we said that z is this, don't it? Yeah, man. We said z is this. All right. So let's write that down. We said that z is equal to root 2 to the 7th power times e to the 21 over 4 pi I. Yes, we said that. But we also know it in its polar form. We also know in the polar form, it is root 2 to the 7th power times the cosine of 21 over 4 times pi plus I sine 21 over 4 times pi. Yes. So this come in very, 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 very handy. So this part is coming in very handy now. You might look at me, you might wonder, why is that very handy? That's very handy because look at this now. Now, root 2 to the 7th power, put that in your calculator. Yes, I know it is sad. Root 2 raised to the 7th power I know how I'm gonna write it. Now root 2 raised to the 7th power. Now, if you were to look at root 2 raised to the 6th power, what would be root 2 to the 6th power? Root 2 to the 6th power would be 8. So I'm gonna write this as 8 root 2, all right, that's root 2 to the 7th power, times, now, the cosine of 21 pi by 4. Put in the calculator, 21 pi by 4, and find the cos of that value. All right, so we're going to put in our calculator 21 pi divided by 4. The cosine of that value is, when I work out the cosine of 21 pi by 4, I get minus root 2 over 2. So I get minus root 2 over 2. That's what my calculator is giving me. Now put this in your calculator, 21 pi by, sine of 21 pi by 4. So I get plus I times, now 21 over 4 times pi, and I take the sine of that value, I'm still getting minus root 2 over 2 as well. So this becomes, I get rid of this, this becomes minus root 2 over 2 times I. Now we're good to go. So now we can multiply them. Multiplying them now, what we're going to get is minus root 2 over 2 times 8 root 2 over 2. Put that in a calculator for me. 8 root 2 over 2 times root 2 divided by 2. And I get 8. All right, so I get this works out now to be this time, this is 8. And so this is, well, minus 8. And then this is going to give me minus 8i. So all I need to do now is factor out negative 8. And I factor out negative 8. And I get 1 plus I. Is so the question easy? Soft. With a capital T. Soft. And so it is proven. So when you prove it, you can say soft. Soft. The capital T. Soft. That takes care of question 1. And that's 25 marks. All right, generally question 1 deals with differentiation and complex numbers. Question 2. Question 2 typically is integration. Question 2 says, determine the integral of sine 2x cos, sine x cos 2x.